So hello everyone, welcome to 4 Dimension Infotech. Today we are going to see about the topic that is gears. So we are going to see different types of gears, their advantages, disadvantages, what are the limitations of the gears, what kind of processes are used to manufacture the gears, and many more things. So to start with, we are going to see what are gears first. A gear is a rotating circular device with teeth crafted to convey torque and adjust speed between shafts, ensuring efficient power transfer. So basically the gears are used for transferring the power from one shaft to another. There are different types of gears here. We can see spur gears, helical gears, rack and pinion, bevel gears, worm gears and internal gears. There are some images of that gears we can see here. We'll see these types of gear one by one now. So first we are going to see here is spur gears. Now a spur gear is the most common type of gear used in mechanical systems. It has straight teeth cut parallel to the gear axis and it is used to transmit motion and power between two parallel shafts, maybe two or more parallel shafts. We can see here the teeth cuts are parallel to the axis of the gear. This is the main thing about the geometry of gear, and they are used usually when the shafts are arranged parallel to each other. Now the key features, before that we'll play this animation here. We can see an animation how these spur gears rotate with each other. I'll put on this animation here. So this is the rotation of this spur gear. There are two gears, in between there is a small gear. Now for proper engaging, we need to ensure that all the modules of these spur gears are together same size. The key features of these gears are teeth orientation. Now talking about teeth orientation, the teeth orientation is straight and parallel to the axis. The shaft arrangement, always the shafts will be arranged in parallel way. The noise level while working with this gear is moderate to high at high speeds. While talking about efficiency, it is high up to 98 to 99%. The manufacturing way is simple and cost effective. Now the load capacity for this gear is moderate. Direction of rotation opposite for the driver and driven gear. So these were the key features of this spur gear. Next, the material used. This is very important factor here, that we should know what kind of material is used for manufacturing the gears. So for spur gear, according to applications we have seen here, for light duty, common material uses nylon, plastic and brass. For medium duty, mild steel and cast iron is usually used. And for heavy duty, alloy steel such as EN8, EN24, etc., which are hardened steel. Next thing we are going to see here is spur gear arrangements. There are different types of spur gear arrangements also there. So the first one is showing here external spur gears. So in external spur gears, both gears have teeth on the outer surface. Internal spur gears, the second type, one gear has internal teeth used in compact gearboxes. Whereas in rack and pinion, a straight rack means flat gear matches with the spur gear. We will see this rack and pinion arrangement further. Now manufacturing of this spur gear. So the ways of manufacturing are different, such as hobbing, which is most commonly used method, then shaping, milling, casting or powder metallurgy, injection molding. Now this is one of the way for manufacturing plastic gears. Applications of spur gears. So these spur gears are usually used in gearboxes, conveyors, automotive transmissions, industrial machinery, watches and clocks, elevators and cranes. Now the advantages of spur gear. Now talking about the advantages of spur gear, they are easy to design and manufacture, high efficiency, good power transmission for moderate loads, easy to maintain and inspect. Whereas there are some limitations also. So the limitations are noisy at high speeds. Means when the gears are working, they are noisy at high speeds. Only suitable for parallel shaft. Now if the shafts are arranged perpendicular or at 90 degrees, we cannot use this kind of gears for the arrangement. So they are only usable for parallel shaft arrangement here. Sudden engagement may cause shocks over wear. So if they are suddenly engaged, they may cause shocks and wear. Now the next type of gear we are going to see here is helical gears. Talking about helical gears. So helical gear is a typical type of cylindrical gear, means the teeth are cut at an angle to the gear axis. Unlike spur gears that have straight teeth. We have seen that in spur gears the teeth are straight, but in helical gears the teeth are cut in helix angle with reference to the gear axis. So this is the main difference between spur gears and helical gears. Now the key characteristics for this helical gears are, first we'll talk about the tooth design. Teeth are cut at an helix. They are engaged gradually, means there is certain helix angle as we have discussed earlier. Smooth operation. More gradual and engagement reduces shock loads and noise. So over spur gear, this is the advantage, that the gradual engagement reduces shocks, loads and noise. Now talking about power capacity, can transmit higher loads than spur gears. There is a factor of axial thrust also. So it generates side thrust requiring the thrust bearings. Talking about direction of helix, can be right hand or left hand. Meshing gears must have opposite helix angles. Means when the gears are meshed, they should be at opposite helix angles. That is compulsory while arrangement. We can see one animation also for the helical gears here. Now types of helical gears. Parallel helical gears. Shafts are parallel, used in gearboxes and conveyors and mechanical drives. Whereas the second type is crossed helical gears. Shafts are not parallel, non-intersecting. They are used in low maintenance applications such as small machine drives. We can see the arrangement for the helical gears here. These gears are engaged in such a way that helix angles are opposite for both the gears. Means one gear is left hand side and one gear is right hand side rotating. Next, the advantages of helix gear. Quieter and smoother than spur gears. They are not much noisy as spur gears. They are a little bit smoother as well as quieter. Capable of handling high loads. More durable due to gradual tooth engagement. High efficiency, that is still 96% to 98%, but it's still low as compared to spur gears. Talking about disadvantages, now there are certain disadvantages also here. It produces axial thrust, needs special bearing types here, more complex to manufacture than spur gears, slightly lower efficiency than spur gears due to sliding contact. So here the efficiency will be little bit low as compared to spur gears because of the sliding contact, and they are little bit complex for manufacturing as there is helix angle in the teeth. Needs special type of bearings also here because of the axial thrust. Now talking about the applications of helix gear, they are used in automotive transmissions, elevators and escalators, conveyor systems, printing machines, industrial gearboxes. Whereas manufacturing methods are gear hobbing, gear shaping, grinding for precision gears, and casting and forging for heavy duty gears. Now we'll see a small comparison with spur gears. In left side we have given some features, and here the performance of spur gear and helical gear has been shown. So according to teeth, they are straight, and here the helical gear is angled. Spur gear is straight. Talking about load capacity, for spur gear it is moderate and for helical gear it is high. Next thing is noise. So spur gear is little bit noisy here, but helical gears are quieter than spur gears. Next point is axial thrust. Spur gear has no axial thrust here, none. But in helical gear, it is kind of disadvantage. It has axial thrust also. So special kind of bearings are required here. We have seen in earlier points that special kind of bearings are required for such kind of axial thrust. Now talking about efficiency, spur gear has high efficiency as compared to helical gear. It is lighter at lower side. Now next type of gear we are going to see here is bevel gear. We can see here the image been given of the motor in which the arrangement of this bevel gear is been shown here with the shaft. You can see the animation also here. Both the bevel gears are arranged at 90 degrees to each other. So a bevel gear is a mechanical gear with conically shaped teeth used to transmit motion between intersecting shafts, typically at 90 degrees. The angle can be changed by 90 degrees also there. Now the key characteristics according to the features. According to shape, they are cone shape, tooth profile, straight, spiral or hypoid. Shaft angle typically at 90 degrees but can be varied. Power transfer between intersecting shaft. Material used for this kind of manufacturing: steel, cast iron, brass, plastic, etc. Now there are different types of bevel gear. We'll discuss them together here. First type is straight bevel gear. Teeth are straight and tapered. Simpler design. Spiral bevel gear. There are spiral bevel gear also. So the teeth are curved, smoother and quieter in operation. Well, the other type is zero bevel gear. Similar to spiral but the zero spiral angle. So the spiral angle will be zero here. Hypoid gear. Offset shafts, high load capacities used in vehicles. So these hypoid gears are usually used in vehicles here due to its high load capacity and offset shaft arrangement. Mitre gear, a special type of gear where both gears are the same size, used of 1:1 speed ratio. So mitre gear is also there. It is a kind of special type where both gears are at the same size. That is, the ratio will be 1:1 for this speed. Now advantages of these gears: they can transmit motion at various angles. They are compact in design, smooth and quiet. In working also they are smooth and quiet, especially in spiral types. Customizable for speed and torque variation. So they can be customized for speed and torque variations here. Now the applications for bevel gears are in automobile differentials, power tools, printing press, industrial machinery, helicopter and marine drives, and conveyors. Talking about the manufacturing methods such as casting, forging, machining such as hobbing, milling and shaping can be used. We can also go for grinding for precision gears. These are the operations or manufacturing methods that can be used for producing the bevel gears. Now there are certain design considerations also while manufacturing this kind of gears. That load capacity should be considered, desired gear ratio to be obtained should be considered, shaft orientation, material strength, noise or vibration tolerance should also be considered here, and lubrication need is also there in bevel gears. Talking about the limitations for the bevel gears, more complex to manufacture than spur gears. Alignment is critical, misalignment can cause failure. Spiral and hypoid gears require specialized cutting tools. So these are the limitations here, that they are more complex as compared to spur gear. Alignment is critical, as well as they need special kind of cutting tools also. So this may increase the cost of manufacturing while manufacturing the bevel gears. Comparison of bevel gear with spur gear. So we'll see one small comparison also here with spur gear. Talking about shaft angle, intersecting oftenly at 90 degrees. Whereas in spur gear, shaft arrangement is usually parallel. Shape is conical here for the bevel gear, and for spur gears shape is cylindrical. Tooth alignment is angular, whereas in spur gears tooth alignment is straight. Now talking about applications, bevel gears, they are used for direction changing drives. In many machines they are used for changing the drives. On the other hand, talking about spur gears, they are used for reducing the speed. They are working as speed reducers here. The next type of gear we are going to see here is worm gear. Now we can see in the image one shaft and one gear is being shown here. Worm gear is a type of gear arrangement that consists of worm, that is a screw which is shown in this figure, and a worm wheel, that is this gear at the downside. It is used to transmit motion and power between non-intersecting shafts that are typically at 90 degrees. Components, there are two main components here. Worm, the first one at the above side, a screw-like shaft with spiral threads like a bolt. On the other hand, the second part is worm wheel, a gear that meshes with the worm, that is mashing with the above shaft which is having teeth here. You can see in animation. Now the working principle for worm gears is the worm gear rotates and the threads push against the teeth of the worm wheel, causing it to rotate. The direction of rotation depends on the direction of worm rotation. Worm gears provide high torque and low speed at output. So here the speed will be low but the torque will be high while the output is given. Types of worm gear. There are certain types of worm gear also here. The first type is non-threaded worm gear. There is no grooves, simple, and they are inexpensive. Means on shaft there will be no grooves. They are simple in design as well as inexpensive. Second one is single throated worm gear, where there is curved wheel for better contact alignment. So the third one is double throated worm gear. Both worm and wheel are grooved. Best contact and torque. So the output of the torque is best, as well as the contact will also be good here. Now the advantages of worm gear: high reduction ratio as well as compact in size. So the reduction ratio is high as well as they are compact in size. Self-locking in some configurations prevents back driving. So they are self-locking, it prevents the back drive here. Smooth and quiet operation. While working they are very smooth as well as quiet operation can be carried out. Handles shocks and loads as well. They can also handle better shock loads here. Now talking about disadvantages: low efficiency due to sliding friction, typically 30 to 50% only. Generates more heat, requires more lubrication. They are going to generate more heat and lubrication will be required here. They are not reversible unless designed for it. Means certain design considerations are to be considered if they are to be made reversible. The material used for making the worm gear. So here the material for worm shaft is used as hardened steel or cast hardened alloy. On the next hand, worm wheel will be manufactured by using bronze, brass or cast iron. Softer for wear and friction. So they are softer for wear and friction. Material properties also matter here. Now the applications for worm gear: in elevators and lifts, in conveyors, tuning instruments, rotating tables, automotive steering systems, gate openers, in hoist and cranes, also in gear reduction boxes. Next type of gear we are going to see here is internal gears. So the internal gears are a type of cylindrical gear where the teeth are cut on the inner surface. We can see here, these teeth are cut at the inner surface here. They match with external gears and rotate in the same direction. Whereas if you talk about spur gears, which will rotate in opposite direction. So when you engage the spur gears, they will usually rotate at the opposite direction. Whereas in internal gears, the gear direction of rotation will be same with the engaged or matched gears. Talking about key features, so there are some features given here, we'll talk about it. Tooth location. Inside circumference we can see here. We can see in this video how these internal gears will work. So I'll play it. And then we'll talk about tooth location. It is inside in circumference. We can see here mating gears. So the gear mating is external spur gear or planetary gear. Direction of rotation same as mating gear. We can see here both of them are rotating at the left side. Gear axis usually parallel, as mostly spur gears are used, that's why the gear axis is going to be parallel here. Pressure angle. So the pressure angle is also going to be same as spur gears. Next, manufacturing of gears. So this type of internal gears can be manufactured by using gear hobbing, gear shaping. Broaching method can also be used here for small and medium sized gears. EDM or 3D printing machines can also be used here for making the job done. Well, typical type of internal gears are straight internal gears, most commonly used. Helical internal gears, smoother and quieter. Bevel internal gears, rare for intersecting axis. Planetary gear systems, which we have seen in this video. This is planetary gear system only. Now the advantages of internal gear is compact design, save space in gear assemblies, same direction rotation, useful in planetary gearboxes, better tooth engagement, means more teeth in contact at once. There are certain limitations also here, such as difficulty to manufacture, especially for small modules. Limited tooth profile options, means cannot be too small or too many teeth. During machining, there is certain kind of risk, that is for tool interference. Now the common applications for internal gears: speed reduction or multiplication, torque control, means they can be used for speed reduction as well as for multiplication. Automobile transmissions, as they are compact and efficient, torque transfer can be done. In robotics, precision actuation in aerospace and satellite drives, as they are compact and lightweight, so the gear systems can be used there. They are also used in watches for internal gear trains in precision mechanisms. Last one, we are going to talk about rack gear. So a rack gear is a linear gear that works with a cylindrical gear called as pinion to convert rotational motion to the linear motion. This is the main purpose for the rack and pinion arrangement, that they will convert rotational motion to the linear motion. Next is linear motion to rotational motion, means vice versa. You can see in image, rack and pinion arrangements are shown in here. This is the rack, a straight gear, and this is the spur gear or helical gear can be used as a pinion gear. Now how the rack and pinion works, a small animation is been shown here, which was made in SolidWorks only. So we can play this animation. Now we can see here, when the pinion rotates, it moves the rack in a straight line. Direction of motion depends on the direction of rotation of the pinion. So overall we can say they are usually used for converting rotary to linear motion or vice versa. You can see here. Now there are different types of rack and pinion arrangement also here, such as straight rack gear. Has a straight teeth cut parallel to the axis of the gear, works with the spur gear pinion, and it is very commonly used. On the other hand, there is another type also in which a helical gear is used for the pinion. So here the teeth are cut at an angle. So in helical rack gear, teeth are cut at an angle. Works with the helical gear pinion only. So working with helical gear, one advantage is also there, that they are quieter and smoother operation than straight racks. So as compared to straight racks, they are little bit smoother as well as quieter. Now the material used for manufacturing rack and pinion is usually steel, that is carbon steel or alloy steel for high strength, stainless steel, corrosion resistance, brass or bronze for wear resistant, low friction. Another type is nylon and plastic can also be used, as they are lightweight, quiet, and can be used for low load applications. Now the manufacturing methods for making this kind of gear is milling, gear shaping, hobbing, injection molding for plastic racks, as well as grinding for precision gears. Application of rack gears, we'll see certain type of industries and their applications here. So in automotive, steering systems, rack and pinion steering. In robotics, linear actuators and grippers. In CNC machines, linear motion mechanisms. In railway, track railways, mountain railways. In elevators and lift, gear driven lifting systems. In gates and door, so automatic gate opening systems. So they can be used for automatic gate opening systems also here. Now the advantages of rack and pinion arrangement is, they are simple and effective in linear motion, high accuracy possible, scalable for various sizes. They are much more durable as well as strong, especially in metal racks. Talking about disadvantages, needs proper alignment. Lubrication is essential to avoid wear, means lubrication is compulsory here. The last disadvantage is here, that they are limited by length for long stroke applications, means the length is limited if you are going to use for long stroke applications. So these were the points we were going to discuss about the gears. We are going to come with more videos like this. So till then, do like, share and subscribe the channel. Thank you.